In this video, we're going to compute the derivative of a function using the definition of a derivative, or what we call the limit process. So I am going to do that by starting by writing out my definition of a derivative. So I know that f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So again, what this means is that I'm going to plug the x plus h anytime there's an x, and this means I'm plugging in x anytime there's an x. So f prime of x equals the limit as h approaches 0 of, so I'm going to take this and I'm going to write it out, and instead of writing an x, I'm going to write some parentheses. Inside the parentheses, I'm going to put this x plus h. Then I'm going to put a subtract sign from the formula, and then I'm going to write a big parentheses, always, and I'm going to write the function out for, instead of writing an x, I'm going to write parentheses, and I'm going to substitute in the x, which really means I didn't really do a whole lot because it just looks exactly the way it was before, and then all over h. I'm going to go ahead and try to simplify this just a touch. So we've got the limit as h approaches 0 of the square root of, I'm going to distribute that in, 4x plus 4h minus 2. And then this would be minus the square root of 4x minus 2 all over h. There isn't a ton I can do with this the way it's in. I need to not have an h in the denominator because I have can't just plug in a 0. So one technique we've learned is that we can rationalize the numerator, meaning we're going to multiply by the conjugate, which means I'm going to switch this sign and multiply both top and bottom by it. So 4x plus 4h minus 2 plus the square root of 4x minus 2 over the square root of 4x plus 4h minus 2 plus the square root of 4x minus 2. All right, so let's see what happens here. Because we're multiplying by the conjugate, we know that the first, when we FOIL this, because that's what this is a binomial times a binomial, my o and my I would cancel, so my shortcut is I could just multiply first and last. So I'm going to multiply this times this, which is just, since it's the same thing, just the stuff underneath. So it'd be 4x plus 4h minus 2. I'm going to put there's a minus times a plus, so it's going to be a minus, and I'm going to use some parentheses. Again, we are multiplying this times itself, so it's just going to be what's underneath, 4x minus 2. The denominator, I'm not going to FOIL it all the way out. I'm just going to, or distribute that in. I'm just going to leave it as h square root of 4x plus 4h minus 2 plus the square root of 4x minus 2. All right, so now I'm going to distribute this in. So we have the limit as h approaches 0 of 4x plus 4h minus 2 minus 4x plus 2 over 4h, not 4h, just h times the square root of 4x plus 4h minus 2 plus the square root of 4x minus 2. All right, now let's look at that numerator. Does anything cancel? It looks like the 4x's are canceling, the 2's are canceling, so I am left with the limit as h approaches 0 of 4h over h times the square root of 4x plus 4h minus 2 plus the square root of 4x minus 2. And now I am noticing that my h's can cancel. So what I have left is the limit as h approaches 0 of 4 over the square root of 4x plus 4h minus 2 plus the square root of 4x minus 2. And then we are going to substitute the 0 in just for the h part. So we get 4 over the square root of 4x plus 4 times 0 minus 2 plus the square root of 4x minus 2. Well, we know this part's going to cancel out. So I get 4 over the square root of 4x minus 2 plus the square root of 4x minus 2. And a radical plus itself, I'm going to just use the coefficients in front and add those together. So I get 4 over 2 square root of 4x minus 2. It looks like I could simplify one more step here. 2 goes into 4 twice. So my final answer is 2 over the square root of 4x minus 2.